Hola. Okay, I'm trying to be creative. Hi, how are you doing, class? Today's lesson is 8.5, and this is problems involving more than one triangle. And we're still dealing with right triangles today. Please be aware that we're having an upcoming quiz, probably the next class or the next lesson, and then we're getting into the oblique or non-right triangle trig. Okay, so let's start with some warm-ups here, folks. Just remember our acronym we like to remember. I'm going to put it here in the middle so that when I do the second part, you can see it as well. Okay, so we're going to take a look at these warm-ups. Take a look at one. Find the value for x. So we've got an angle, so that becomes our reference, folks. What two sides do we have information on? The opposite side and the adjacent side. So that tells us we're using the tan ratio. So it's going to be tan of the angle, which is 23 degrees, equals, it goes in order, folks, the opposite side, which is x, over the adjacent side, which is 4. Cross multiply because x is on the top. So it's going to be 4 tan 23 degrees. Plug it in your calculator, folks, and you're going to get 1.7 feet. Okay, remember we don't really leave that as a final answer, so we're going to go x equals approximately 1 3/4 feet. Or you could change it to inches. So for those people who are good with woodworking, I'm just going to take 0.7 times it by 12, and that's roughly 8. So you could say or 1 foot 1 foot and 8 inches. All right. Taking a look at warm-up number 2, we've got an angle of reference that is 63 degrees. What two sides have the information on? We've got the hypotenuse and the adjacent. So again, in SOHCAHTOA, one has an A and an H in it. That is your cos. Okay, or your cosine. So it's going to be cos of 63 degrees equals, and again it goes in order, adjacent, which is 0.5 divided by your hypotenuse, which is x. Notice x is on bottom, folks. You got to do the switch. Put it on top. So x equals 0.5 divided by cos of 63 degrees. Okay, plug it in your calculator, ladies and gentlemen. X equals 1.1 kilometers. So far, so good? Awesome. All right, example 2 for your warm-up. Now we're finding the angle. So it asks you for angle L. Okay, so taking a look here, folks, for 2A, where do we have our information in? The opposite side and the hypotenuse. But I want you to star this. Why do we have to be careful with this one? Okay, look very carefully. The opposite side is 3.5 meters, and the hypotenuse is 560 centimeters. Whenever we do ratios, folks, we always have to have same units. So you got to watch here for same units. Okay, so you could do one of two things. You could change the meters into centimeters or the centimeters into meters. I think it's easier just to change the centimeters into meters. So there's 100 centimeters in a meter, so I'm going to cross that out and go 5.6 meters because you have to have equal units because it's a ratio, right? You're comparing things and a ratio has to have the same units. Okay? Now that we've got our same units, let's just quickly go over again. We've got the opposite side and the hypotenuse with the same units now. So opposite and hypotenuse, ladies and gentlemen, is going to be the sine ratio. So you're going to go sine of angle L, which is L, equals, go in order, the opposite side, which is 3.5, over the hypotenuse, which is 5.6, same units, okay? Angle L equals the sine inverse of this fraction. Okay, so angle L equals 39 degrees. All right, let's try the next one. Okay, angle L is our angle of reference, so we're trying to find what two sides have information on it. We have the adjacent side and the hypotenuse side. Good news is they're the same units. So we are going to use, going to our ratio A and H, that's going to be our cosine. So we're going to go cos of L equals, again, go in order, the adjacent side, which is 5, divided by the hypotenuse, which is 13. To find the angle, you got to use the inverse, so it's the cos inverse of 5 divided by 13. Plug it in your calculator. Angle L equals 67 degrees. Awesome. That is what you should be prepared for on your unit test. Okay, or on your, sorry, back that up. On your quiz coming up, all right? Again, you're going to know SOHCAHTOA. Tell me which ratio, when to use which ratio. Now we're going to get into a little bit of harder stuff with dealing with more than one triangle, and we're going to learn some new terminology. So today we're dealing with problems involving more than one triangle, okay? And we need to learn two common angle descriptions, okay? The first one's called the angle of elevation. It's the angle formed upward from the horizon. So my horizon is always a a horizontal line. So I'm going to put horizontal, okay? And you're going up. Okay, so this is the angle of inclination, is the angle going up. I think I feel elevated, I feel high, I feel happy, I'm moving up. Okay? Whereas the angle of depression, okay, is the angle formed downward from the horizontal. So if I've got the horizontal here, and I'm going down, it's the angle going down. Okay? Notice there's a direction on the arrow. Okay? So how I can think about this is if you're taking a plane, say you're going on a trip to Florida, and you're taking off. When you take off and leave the ground, you head up in the air at a certain angle. That's the angle of elevation. So maybe the plane tells the pilot, because it's automated, you need to take off at a 45-degree angle. So as soon as he's ready, he's got enough speed, he's going to, go up at a 45-degree angle. Okay? Vice versa is when you're landing, you need to have a certain angle to come down at. So maybe you're coming down at a 22-degree angle. That's the angle of depression when you're landing. Okay? All right. Let's take a look at applying some of these to some word problems. Okay? So example 1, the distance between two office buildings is 73 meters. From the top of the shorter building, the angle of elevation, so that's going up to the top of the taller building, is 31 degrees. So, whoa, just so we don't get confused. We know now that we got two buildings. One's taller, make that one tall, and then I'll make this one smaller, right? And hopefully when we got a buildings on a street that they're on the same point. Okay, so we've got a taller building and a shorter building. And it says the distance between the two buildings, so from here to here, we know is 73 meters. All right, it says from the roof of the shorter building, so right here, okay, to the top of the taller building, so I'm going to draw a straight line to the top of the building, it says the angle of elevation is 31 degrees. So I've got to draw my horizontal, which is straight across, and it's the angle going up. And we say that it is 31 degrees. Okay? At the same location, the angle of depression, which means we're going down, okay, to the bottom of the taller tower is 42 degrees. Okay, so that's the angle going down. Okay. Whew, that looks pretty interesting. Okay, it says calculate the height of the taller tower. So we eventually need to get this complete distance. Okay? So we need to get that. However, all of our information is in two other triangles. I want you to make a note that the horizontal and the building should be 90 degrees. So I want you to take a look that we've got an upper triangle right here, right, where information is in, and we've got a lower triangle right here, where information is in. Okay? You also need to remember, folks, is the 73 meters is the distance from the two buildings. That's the same distance at the horizontal, so that can be brought into your triangle. Okay? And that's used for both the top and the bottom triangle. Okay, because it's the same distance used here. So ladies and gentlemen, if we can use the two triangles and first find out the height on the top triangle and then find the height of the bottom triangle, we could take the two answers and add them up, because x is just going to be from here to here and y is going to be from there to there. So to find the height, it's going to be x plus y. Okay? Everybody okay with that? So again, with these questions, we're using more than one triangle to help us. Okay? So I'm going to write down let x plus y represent height of taller building or taller tower. Okay, everybody good with that? All right, so let's find x first. So our angle of reference on the top triangle is 31 degrees. So we have an opposite side and an adjacent side, so that's going to be tan. So it's going to be tan of 31 degrees equals the opposite side, which is x, divided by the adjacent side, which is 73. X is on the top, so you cross multiply. Plug that in your calculator, ladies and gentlemen, and you're going to say x is approximately 43.9, and our units are meters. Okay, so we know part of the height of the building. Okay, so if the question asked you saying how much taller is the big building compared to the small building, you could tell me it was 43.9 meters, but it didn't ask that. It said what's the total height of the tower. Okay, so what we need to do is find the y first, or y next. So using the y, ladies and gentlemen, we've got the angle of 42 degrees, we've got the opposite side, and we've got the adjacent side, so we're using tan again. So we're going to go with tan of 42 degrees equals y divided by 73. Cross multiply, so y equals 73 tan 42 degrees. Plug her in your calculator, and y equals 65.7 meters. Okay, we're not done yet. We need to finish the question. Okay, so what we need to remember to do is go x plus y equals 43.9 plus 65.7, and that's going to equal 109.6. And a therefore statement because it's a word problem. So therefore, the taller building or taller tower is 109.6 meters. Cool. All right, let's take a look at another example, number 2. Number 2, two contestants on Survivor are 30 meters apart. An apple is placed on the ground, equal distance between them. All right, so let's pretend this is contestant A here, and we got contestant B here. And they say there's an apple right between the two of them. Okay, so this is my apple. Oh. Okay. And if the two contestants are 30 meters apart and the apple is located halfway or equal distance, we know that this is going to be 15 meters and this is going to be 15 meters. Okay? Where it splits there at the apple. Okay? Total of 30. Okay? And then it says the apple forms the angles of elevation of 5 degrees to the top of and 6 degrees to the top of their heads. So we can just pretend here's contestant A. We'll make her a girl. Okay, and since it was said respectively, we'll do 5 degrees first. Okay, and then I don't know, contestant B, will make him a man. Okay, and they say the angle of elevation to the top of their head is 6 degrees. Okay, and hopefully we realize that people stand at a 90-degree angle. Okay, usually. Okay, and now the question says, how tall are the two contestants? Well, let's label them differently. So let's go X and Y. So we're going to say, let X represent height of first person And we'll let y represent height of second person. All right, cool. So ladies and gentlemen, each triangle we have an angle of reference. So we've got to figure out if we're looking to solve x first. We've got an angle of reference of 5 degrees. What two sides do we have? We have the opposite and we have the adjacent. So we're going to use the tan ratio. Again, that's the most familiar one. You're going to see it in real life more than the other ones. Okay, so it's opposite side over the adjacent. So x equals 15 tan 5 degrees. And it says that contestant A, or the first person, is 1.3 meters when you plug it in the calculator. Let's try to find y. So to do y, again, you've got an angle of reference of 6 degrees. And what two sides do we have? Opposite and adjacent. So again, it's tangent ratio. So we're going to go the tan of 6 degrees equals the opposite, which is y, over the adjacent, which is 15. Y equals 15 tan 6 degrees. You need to show that step. And y equals 1.6 meters. So don't forget a therefore statement. Don't put therefore x equals and y equals. You say therefore the two survivor heights, or contestants if you want to put it down there, are 1.3 meters and 1.6 meters. Awesome. Okay, let's do one more example. And this is kind of really cool, this last example. You ready? Let's do it. Okay, a fire is sited in between two fire towers that are located 20 meters high. So ladies and gentlemen, in the logging industry, because there's many acres of land, they build fire towers to monitor if there's any forest fires, because forest fires can just happen naturally, especially out in BC and California. Nowadays, ladies and gentlemen, they can use satellite, which is a lot easier. But back in the day, before before technology improved, we had to have fire towers. I remember tree planting out in Alberta and BC and running across a couple fire towers while I was tree planting. All right, so take a look here. It says a fire is sited between two towers that are each 20 meters high. So here's tower 1, 20 meters high. Okay, here's tower 2, which is 20 meters high. Okay, and it said if the angles of depression from each, let's put the fire somewhere in the middle here. Do you like my little fire? There we go. Okay. Question, sorry, let me just fill this in. Okay, so it says if the angles of depression from each tower to the fire is 32 degrees. Now be careful here. If I'm looking down at this fire, and here's my biggest mistake people give me, okay? What they do, don't write this in, they say, 32 degrees. That's the angle. I said, I'm going to back that up because it's wrong. The angle of depression occurs from the horizon down. So there's my big key. So make sure you get that. So it's 32 degrees. It's outside the triangle, okay? But we can fit it in there in just a second. Okay, so 32 degrees for the first one and 26 for the second one, and again it's outside. Okay, how far are the two towers? So folks, we realized that we have two triangles here, and to get how far apart the two towers are, we're going to have to do x and y and add them up. Okay, so to get the total distance, it's going to be x plus y. Okay, there are two ways to solve this and to get the triangle in. Get the angle information inside the triangle. One thing you could do, folks, which I choose not to do, you could take 90 degrees, subtract 32, and get this angle in here. However, an easier way to do it, and without having to do a mathematical calculation, is to remember something. The horizon and the ground are parallel. So remember the parallel line theorem Z pattern? Okay, probably from grade 9 or grade 8. That brings that in at 32 degrees. It's much easier when you bring it inside the triangle without having to do a calculation. So likewise, if I try to do the Z pattern on the second one, ladies and gentlemen, it's a it's going to be 26 degrees here. Okay? All right, so let's do a let statement here. So we're going to say, let x plus y represent distance between, you can use the short form, towers. Okay? All right, so let's find x first, guys. So to find x, what information do we have? We have the, from angle 32 degrees, we have the opposite and the adjacent. So again, we're using tan, but that's just common, guys. So please don't say, Miss R, tangent again. But in reality, we use that most of the time. Okay, so tan of 32 degrees equals 20 divided by x. X is on the bottom. Don't forget to get it on the top. You got to switch it out. So it's going to be x equals 20 divided by tan of 32 degrees. Plug it in your calculator, and x equals approximately 32.0 meters. Even if it's 32 exact, put the decimal zero in because we always round to one decimal place. You're showing a higher degree of accuracy. Okay, let's find y, folks. So to find y, we've got an angle of 26 degrees. And again, we've got the opposite and adjacent side. So tan of 26 degrees equals opposite side, which is 20 divided by y, which is on the bottom. So you've got to switch it out. So I go y equals 20 divided by tan of 26 degrees. So y equals 41.0 meters. Okay, don't forget, folks, it's x plus y. So you add those two together. So it's 32.0 plus 41.0 equals 73.0 meters. And put her in a therefore statement. So therefore, the two towers are 73.0 meters apart. Great. Hope you enjoyed that lesson, folks. I find this is always fun doing trigonometry and applications. Please be aware of your upcoming quiz. And after your quiz, we're going to get into the oblique triangles, which are the non-90-degree triangles. Okay, so if you're sick and tired of drawing right triangles, we're going to take a break and get onto some other triangles. Okay, here's your homework, guys. Page 429, numbers 1A, 2B, try 4 to 8, and come see me if you need any help. Have a fabulous day, class.